right, welcome to the living answer key for mole conversions. It says mole conversions at the top of the worksheet. A couple things that we need to make sure that we know. We need to know that we know moles equals mass over formula weight. And we also need to make sure that we know that we have a periodic table and a calculator. I would say at any point in time during this recording, if you want to stop and try the problem by yourself and then push play, or if you are wanting to go to the end of the worksheet and do that, I'm going to do every single problem so that everybody can see how it needs to be worked out. But you may skip and pick and choose where you want to go on this. Okay, for the first one. So if we are given, okay, grams, and that means that I need to find moles. So that means my X is going to be on the outside. So we're looking for moles, and I'm given grams, and so I'm going to do 2.62 grams. And now we have calcium chloride. You look up, calcium is 40, and then chlorine is 35 times 2. Okay. And when I get that, I get a mass of 110. And then how do I solve this problem? Well, it's very simple. All you do is you do 2.62 divided by 110, and your answer will be 0.024, and then you always need a unit. Remember, now we've converted it into moles. And I do suggest you get to know your units. Number 2, I'd have you try it and then push play. All right, so now I've been given moles. So unlike the other thing, I've been given moles and I want to find mass. So what I'm going to do is I'm going to write my 1.32 moles of baking soda. And I want to find my mass. And then I need to put a formula weight down here. So I have 1 sodium at 23, I have 1 hydrogen at 1, I have 1 carbon at 12, and then I have 3 oxygens at 16 apiece. If we multiply that and add them all up, you're going to get 84. How do we solve this problem? Well, I know 84 is on the bottom, so I'm going to multiply this by 84 to get rid of that, and that means we need to multiply this side by 84. And boom, I get an answer, 103.32. And now I found X, which is grams, and put the formula. All right, let's have you try the next one. Pause it, and then we'll go. All right, this information is moles, so that means that I want to find grams. 1 zinc, 2 chlorines gives me 135, and then I'm going to multiply both sides by 135. How did I get that? 1 zinc, 2 chlorines, 75.60 grams of zinc chloride. Zinc 2 chloride. Do the next one. All right, I have grams of my carbon dioxide. I want the moles of carbon dioxide, so I find the formula weight. 12.4 divided by 44 gets me 0.28 moles of CO2. All right, try the next one. I'm looking for moles. I have grams and 1 barium. Be very careful. We have 2 nitrogens and 2 times 3, 6 oxygens. So check your formula weight. Should be 261. Divide 0.96 by 261 and you get a nice small number here. 0.0037 moles of barium nitrate. And last but not least, try the last one. All right, you have this number of moles. I'm looking for mass. 1 calcium, 2 oxygens, 2 hydrogens. Gets me 74. Multiply both sides by 74. 5.3 grams of calcium hydroxide. All right, now we're at the bottom half. We talked about, okay, when you pull this apart, every time you get 2 hydrogens and 1 oxygen. So if I had 10 waters, I would get 2 times, I get 20 hydrogens and 10 oxygens. So what we do is we just take the subscript and we multiply by what we're given. So to find the hydrogens, I do 2 times 360, which is 720, 1 times 360, which is 360 for the oxygen. Okay, pause at any point in time, and then you can just watch me go here. 34, 1 nitrogen, so 34, 3 hydrogens every time times 34 gets me 102. If I have 10 moles of sodium bicarbonate, every time I pull it apart, I get 1 sodium, so 10 of those, 1 hydrogen, so 10 of those, 1 carbon, so 10 moles of those, but then I get 3 oxygens every time, so it's going to be 30. All right, now, if I pull it apart, every time I get 2 hydrogens, I'm going to have 9 times 2 is 18 moles of hydrogen. I have 1 sulfur, so 9 moles of sulfur. 4 times 9 is going to be 36 moles of oxygen. Calcium, 1 of them every time, so I get a 50. 1 carbon every time, so I get 50. But then 3 times 50 is 150 oxygens. And then we get a nice challenging one here. There's a misconception here, so hopefully you got this right. I have 1 aluminum, so I'm going to get 5 moles of aluminum. I have 3 nitrogens, so I'm going to get 15 moles of nitrogen. And then 3 times 3, not 3 plus 3, 3 times 3 is 9. 9 times 5 is going to give me 45 moles of oxygen. Okay? All right, so we did this one in class. So if you saw it, you can skip it. If you've not seen it, here we go. We're going to kind of put everything together now. Okay, we have how many grams of each element are present. So the first thing we need to do, we cannot compare iron and oxygen in grams. Whenever you see grams, you should have an inkling to want to change it to moles. So the first thing that I'm going to do is I'm going to find moles of my whole thing. And remember, we know that moles, again, this will be your favorite unit, or your favorite formula. Moles equal mass over formula weight. Okay. So what we're going to do here is I'm going to have my mass, which I have is 14.4. I'm going to put it over the formula weight of my whole thing. So Fe2O3. So 56, 56, and 3 16ths gives me a formula weight of 116. When you do that, you get 0.09 moles of the whole compound. Now, just like we did on the front, if every time I pull this apart I get 2 irons and 3 oxygens, in order to figure out how many moles of iron I get, I need to multiply that by 2. So 0.09 times 2 is 0.18 moles of iron. And what would I do to the oxygen? Multiply it by 3. 0.27 moles of oxygen. Now the question here though said, how many grams do I have? And these are moles. So again, I know that moles equal mass over formula weight. So if I have moles of iron, and I'm looking for mass of iron, I will put it over the formula weight of 1 single iron. Okay, I don't need to do 2 of them because I already took into account how many. I need a 56. So 0.18 times 56 is going to give me 10.8 grams of iron. And then now I have 0.27 moles of oxygen in this sample. I want the mass of oxygen over the formula weight of oxygen, which is 16 off the periodic table. I multiply these two things together, and I get 4.2 grams of oxygen. Now, I add these back together in my head. Awful close to 14.4. That means I did it correct. I'll have you pause the program and try the next one. Play it when you're ready to watch. Alright, so again, first step, you got to figure out how many moles you have of this. So, I want moles of sulfuric acid. I have 154 grams of it. I'm going to divide it by the formula weight of 2 hydrogens, 1 sulfur, 4 oxygens. Add them all together, you get 98. Once you divide that, you're going to get 1.75 moles of your compound. I'm going to multiply this times 2 to give me my hydrogens. I'm going to multiply this by 1 to get my sulfurs. And I'm going to multiply this by 4 to get me my oxygens. Now all I have to do is tell you how many grams each of these have. Moles equal mass over the formula weight for 1 hydrogen is 1, so clearly that's nice and easy. You're going to get 3.14 grams of hydrogen out of that. Moles equal mass over formula weight of 1 sulfur is 32. Multiply 1.57 times 32, we get that. And then last but not least, we do X over the formula of 1 oxygen is 16. Multiply both sides by 16 and we get 100.48 grams. Now, once you add those back together, you get very close to 154 and life is good. Next one, I would say pause the program, see if you can't do it, and then come back and see how you did. All right, like we said, first step, you got to take what you have, you got to put it into moles. I take what I have, divided by 3 sodiums, 1 phosphor, 4 oxygens. That's going to give me 0.027 moles of my compound. I multiply this times 3 because I have 3 sodiums. I multiply this times 1 to figure out my phosphorus. And I multiply this times 4 to figure out my oxygen. Okay, hopefully everybody understands why, because every time I pull it apart, I get 3 sodiums, 1 phosphorus, and 4 oxygens, just like we did on the front. Now, the answer wants to know how many grams of each, though. So I do moles equal mass over the formula weight of 1 sodium. This number times 23, 1.86 grams of sodium. Phosphorus formula weight is 31. Multiply those together and you get 0.84 grams. And then again, oxygens, you'll have it memorized by the end of the unit here. Oxygen is 16. You get 1.76 grams of oxygen. All right, I'd say pause the program again. See if you can't get this one. All right, again, you're going to start by putting everything you know into moles. So I'm going to take my mass here, put over the formula weight of 3 calciums, 2 phosphorus, and 8 oxygen. Nice big number here, we're talking 310. Divide 173 by 310. And you get, very good, 0.56 moles of calcium phosphate. Now I want to know how many moles of calcium, how many moles of phosphorus, and how many moles of oxygen come out of this sample of calcium phosphate. I do 3 times 0.56 to give me 1.68 moles of calcium. I do 2 times 0.56 to get me 1.12 moles of phosphorus. And I do 8 times 0.56, okay, to get me 4.48 moles of oxygen. Now again, it asks for grams, so I have moles of everything. Moles equal mass over formula weight. I'm looking for the mass of calcium over the formula weight of calcium. 1.68 times 40 gives me 67.20 grams of calcium. Okay, X over 1 phosphorus is 31. Going to get a number there, 34.72 grams of phosphorus. And then again, always good old oxygen ended up with. Okay, we're going to do 16 times our number. We're going to get 71.68 grams of oxygen. All right, we're down to 2 more, I would definitely say. If you haven't stopped to try to do them by yourself, you should stop now. Try to do the next 2 by yourself. All right, so we're going to find moles of ammonium carbonate. First thing I'm going to do is I'm going to take my mass over my formula weight. I have 2 nitrogens, 8 hydrogens, 1 carbon, 3 oxygens. We're looking at 96 as our formula weight. You divide that, you get 2.04 moles of your whole compound. Now I got 4 elements today to worry about. Already my 4th one yet. Okay. What we're going to do here, so I have my nitrogen. So I'm going to do 2 times this to get my nitrogen. I'm going to do 8 times 2.04 to give me my hydrogen. I'm going to do 1 times 2.04 to get me my carbon. And then I'm going to do 3 times 2.04 to get me my oxygen. Hopefully everybody understands that. Now, I want to know the mass. How many grams is 4.08 moles of nitrogen? X over the formula weight for 1 nitrogen. Multiply those together and you're looking at 57.12 grams of nitrogen. Hydrogen, X over 1. Multiply, you're looking at 16.32 grams of hydrogen. 1 over 12 for your carbon. Multiply 12 by both sides and you get 24.48 grams of carbon. And then oxygen's always bringing up the end. 1 over 16. Multiply both sides by 16 and you get 97.92 grams of oxygen. All right, last one. Make sure you pause the program. Try it out. All right, you take what you have, put it into moles. 5.23 grams of aluminum nitrate. 1 aluminum, 3 nitrogens, 9 oxygens gives you a total of 213. Divide those numbers, you get 0.025 moles of aluminum nitrate. Now I'm going to do 1 times this for aluminum. How many nitrogens do I have? 3 times that number for nitrogen. And how many oxygens do I have here? Good, 9 times that number for your oxygen. Now I'd like the mass of each of these, so pause if you haven't figured it out. Moles equal mass over formula weight, which happens to be 27 for aluminum. 27 times 0.025 gives me 0.68 grams of aluminum. X over the formula weight, 14 for nitrogen, so 14 times 0.075 gives me 1.05 grams of nitrogen. And then X over 16, 16 times 0.23 gives me 0.368 grams of oxygen. Hopefully you're feeling good with this. We'll have a mini quiz soon. Make sure you bring any questions you might have to class.